The subject is electric measurement and control. Electric measurement and control. The chapter is the control system. Control system. Today I will discuss about the block diagram reduction technique. Block diagram reduction technique. Block diagram reduction technique means two or three or more block diagram included in one system. The two and three block will reduce by particular a system. The output result is a one block. Output result will be the one blocks. Okay, I will do this. Heading is block diagram reduction technique. Block diagram reduction technique. Here it's a summing point and the G1 is a transfer function and G2 is another transfer function. This is called the summing point. This is a transfer function and G2 is another transfer function. R is a input and C is output. The H1 is feedback element is connected to the output and another point is connected to the summing point is plus is minus. Here the G1 and G2 two transfer function. H1 is a feedback element and it is called the feedback path. It is called summing point. So here the two transfer function G1 and G2 is connected in series. G1 and G2 is connected in series. Then the step 1 and step 1 G1 and G2 is connected means G1 with multiply with G2. G1 is multiply with the G2. Then summing point is multiply with G1 and G2 within one block. And R is input, C is output, and H1 is feedback element. And same is a plus, so minus. Step 1 and step 2. When two are transfer function G1 and G2 is connected in series, then their output result is G1 into G2. The transfer function the GS, the formula is GS by 1 plus GS into HS. Already we have discussed the previous class. G1 and G2 total is a transfer function. GS by 1 plus GS. GS means G1 G2. H1 R is input, C is output. Therefore, the transfer function is C by R is equal to G1 by G2 divided by 1 plus G1 to G2 into H1 is the output result. We'll take the another example. Another example, a summing point G1, the another summing point and the transfer function G1, another transfer function G2 are connected in series. The feedback path is H1 is the feedback element in each. R is input, output is C. Another feedback path without feedback element. There is a minus, it's plus. Reduce the each diagram to a single block and hence determine the resulting equivalent transfer function. The same procedure we will take because the transfer function G1 and G2 is connected series. Then the G1 is multiplied with the G2. G1 into G2 and the feedback element H1, another feedback path without feedback element. The R input, C put is plus minus the step 1. Step 2. Here the H1 is a feedback element and another feedback path. There is a no feedback element. We will assume this path has a feedback element is 1. Here the two feedback path, one is here and another is two feedback path. They are connected as parallel. Then the result will be the H1 plus 1. When a two transfer function is connected parallel, then the result is G1 plus G2. When the two feedback element is connected to the parallel path, then the result is H1 plus 1. Here is a no feedback element. We assume the feedback element is 1. Then the step 2, the summing point is also same, the G1 and G2, and C is input, R is input, C output, then 1 plus H1 because two feedback paths are connected in parallel. Then the result will be 1 plus H1. This is a plus and minus. Now three. Step three. The transfer function will be gs by 1 plus gs by 1 plus gs into hs, or g by 1 plus g into h. Here the g1 and g2, 1 plus h. Here the h 1 plus h1, and g is g1 g2. G2, and the R is input, C is output. The last step, output by input is equal to G1 by G2, 1 plus G1 G2 plus G1 G2 into H1. This is the transfer function. This is another example. Here the G1 and G2 are connected in parallel. G1 and G2 is connected in parallel. Then the result will be the G1 plus G2. The summing point is fixed. The G1 plus G2. And here and the G3 is another transfer function. The output C. H1 so minus so plus. This is step 1. Step 2, the summing point, the G1 plus G2. The transfer function, here the feedback element is H1, then the result will be, and the G, here the transfer function is G3. The transfer function is G3, and then G is by 1 plus G3 to H1. And then the feedback path plus is minus the input R and C. See, the both our function are connected in series. And then the result is step 3, the summing point G1 plus G2 and multiply with G3. G3 in bracket G1 plus G2 by 1 plus G3 H1. plus minus r. See, the feedback path without feedback element. The feedback element is suppose 1. Then the result will be gs by means g by 1 plus g into h. Here the g3 by g1 plus g2 by 1 plus g3 h1 by 1 plus g, here g3 by g1 plus g2 by g3 h1. Here it is the whole part is g, or here the h is 1. The value of h is here 1. The 1 is multiplied with the whole number is 1. Or see the step 4.